Welcome to another session. So in this session, we're going to be looking at the exponential function. So the general formula for this is given by y is equals to a multiplied by b raised to exponent x minus p plus or minus q here, whereby the value of p always must be greater than 0. So now when we explore this, the value of a determines the shape of the graph as well as the side of the asymptote where the exponential graph lies. Then when we talk of the value of b here, on the function it plays a role that the function is increasing or decreasing. Then our q value determines the vertical shift. This is for vertical shift, and also it's for the horizontal asymptote. Alright, so if our value of a is greater than 0 and also our b value is greater than 0, then we're going to have something like this, whereby our y is equals to q. Then we're going to have a graph like this, increasing in that way. But if we have our value of a which is less than 0, and then our b value is greater than 1, then we're going to have a shape like this. We're going to have an asymptote somewhere around here, and then our graph will decrease this way. Then there is a point whereby we will be having a greater than 0, but our b value will be restricted between 0 and 1. So in that case, we are going to have something like this. We're going to have our asymptote here near the line x-axis, and then we'll have a graph like this. Then if our a value is less than 0 and then our restriction is still the same, we're going to have, we reflect this graph. It's like we're reflecting this graph. Then we're going to have a shape like this. So these are the effects of a, b, and q. So I want us to look at an example to see how can we sketch the graph of the exponential function. So let's suppose we are having a function f of x which is equals to the array multiplied by 2 raised to exponent x minus 6. Then we are supposed to sketch the graph of f of x. Okay, so now you can see that this is the value of a, this is the value of b, and this is the value of q. Remember, q can act as our vertical shift or the asymptote, the horizontal asymptote. Okay, so the first thing that we need to do is to find our intercept. So for the x-intercept, we can let our y value be equals to 0. Then we're going to have 0, which is equals to 3 multiplied by 2 raised to exponent x minus 6. And then we take the 6 to the other side. Then we're going to have positive 6, which is equals to 3 multiplied by 2 raised to exponent x. Then we can divide both sides by 3. Then now we're going to remain with 2, which is equals to 2 to the power x. So now we're having the same base. We can equate the exponent. Then it means our exponent x is equals to 1. So this is our intercept. This is our x-intercept. We know that our x value here is 1. Then our y value it's 0. Then we can find the y-intercept. The y-intercept by letting our x value be equals to 0. Then we're going to have y, which is equals to 3 multiplied by 2 to the power 0 minus 6. And then when you deal with that, we're going to get negative 3. Then now it means in coordinates form, we're going to have x value as 0, and then this is minus 3. Then our asymptote, our y asymptote, it's going to be the value of q, which is negative 6. Then now we have everything. Then we just need to plot our points and join them on a Cartesian plane. So this is our Cartesian plane like this. This is our x-axis, this is our y-axis. And then our asymptote is negative 6. Then we can assume it's a point here. So this is the point y is equals to minus 6. And then we have our x-intercept as our x-intercept is this one as point 1 is to 0. Then it can be a point here, 1 is to 0. And then we have a point 0 is to negative 3, which is a point here. Then you can see that the graph will increase in that direction. So this is our graph of f of x, which is equals to 3 multiplied by 2 raised to exponent x minus 6. Remember, this point here, it's 1 is to 0. And then this point here, it's negative 3 is to, it's 0 is to minus 3, not vice versa. So it's 0 is to negative 3. So this is how one can sketch their graph of f of x. Then what if we're having y is equals to 1 over 2 raised to exponent x plus 1, and you are supposed to sketch this graph. All right, we can see that our asymptote in this case, our asymptote, it will be y is equals to the value of q, which is 1. Then we can find our intercept. So when we find our intercept, we going to say for y-intercept, we let our x value be equals to 0. Then y now becomes 1 over 2 raised to exponent 0 plus 1. And then we're going to get anything raised to exponent 0, it's 1. Then we're going to have 1 plus 1, which gives us 2. So in coordinates form, we're going to have 0 is to 2. Then for the other intercept, we're going to let our y value be equals to 0. Then it means we're going to have 0, which is equals to 1 over 2 raised to exponent x plus 1. Then we can take the 1 to the other side. We're going to have negative 1, which is equals to 1 over 2 raised to exponent x. Then we can see that there is nothing we can do in order to solve this. So it means here there is no solution, or there is no x-intercept, meaning that x is the element of real numbers. If there is no solution, it means x is the element of real numbers. Then with this information that we have, we can sketch a graph. We can sketch a graph when we draw our Cartesian plane like this, our x-axis, our y-axis. Then we know that our, actually let me do this. Okay, this is our x-axis like this. So our intercept is at y is equals to 1. So we're going to have our asymptote here at this line is y is equals to 1. And then we only have the y-intercept, which was 0 is to 2. 0 is to 2 can be a point here. Then we're going to have our graph like this. Then the graph will approach the asymptote. So this point here, it's 0 is to 2. Then this is your graph of y is equals to 1 over 2 x plus 1. Okay, so they can say determine the domain and the range of this graph. Looking at this graph, we can see that the values of x are possible all over this function, because our x values are here. Maybe this is x is equals to 1, x is equals to 2, x equals to 3, 4, 5, 6. Our x values and the negative x-axis are possible on this graph. So our domain, in our domain, we can say x is the element of real numbers. Then when we talk of the range, we talk of all the possible y values that are possible on this graph. So our graph is possible, but when you see the asymptote, our graph must never touch the asymptote. So it means y, we know that y is the element of real numbers, but our y value must never be equals to y. We can say y is the element of real numbers, but y must never be equals to the asymptote. Or one can say y is the element, okay, from, we don't include it, we don't include 1 up until positive infinity, because anything from 1 going down, there is no graph there. But from above 1 or exactly approximately at 1 going upwards, then we have a function there. So this is how we can write the domain and the range of a function. I hope it makes sense for now. I hope it makes sense. We were just sketching here, learning how to sketch this exponential function. So now I think we should do a question so that we can see how the examiner poses his or her questions to us. They say sketched below is the graph of h of x, which is equals to a raised to exponent x, whereby a is greater than 0. Then they've given us that r, which is this point here, is the y-intercept of h. Then there are points p, which is 2 is to 9. We can see point p here. And then we also have point q here that lies on our graph h. So this is our graph that we are given. It has points q and p and also point r, which is the y-intercept of our function. Then when we go to our questions, they say write down the equation of the asymptote of h. They want to know the asymptote of this graph. So when you look at this graph is approaching this line here, then this side is increasing. So it means that the asymptote for this is the x-axis, because you can see that it is approaching the x-axis, but it's not going past the x-axis. So we know that here on the x-axis, every y value here is equals to 0. So our equation of the asymptote will be y is equals to 0, just like that. Then we move to the second one. They say determine the coordinates of r. Remember r, they said that this is the y-intercept of our graph h. So we can find the y-intercept of our graph. So here we're looking for the y-intercept, whereby we're going to let our x value to be equals to 0. Our equation of the graph is y is equals to a raised to exponent x. And then we're going to have x is equals to a to the power 0. And then now this will be y is equals to 1. So the coordinates of r, we're going to have 0 is to positive 1. So this point here, it's 0 is to 1. So this is these are the coordinates of r. Then they want us to calculate the value of a. They want us to calculate the value of. So how can we calculate the value of a? Remember, we find our value of a from the equation of this, which is y is equals to a raised to exponent x. So to calculate the value of a here, we can use these points because we know the x and y coordinates in order to find the value of a. So we're going to use point P in order to determine the value of. So we're going to use point P, whereby point P we know that is 2 is to 9. And then we have our function y is equals to a raised to exponent x, where we see these are our coordinates, okay? let me do this. This is x and this is y. So where we see y, we're going to put 9. Where we see x, we're going to put 2. So it means we're having 9, which is equals to a to the power 2. And then how do we deal with this? Then we can find the square root both sides. Then our a value now becomes plus or minus 3. This is plus or minus 3. So you can see that our graph is increasing, and they told us that a must be greater than 0. So it means that the correct value here is a must be equals to positive 3. So it means the value of a now is positive 3. Then the fourth question, they're telling that D is a point such that DQ is parallel to the y-axis and our DP is parallel to the x-axis. They want us to calculate the length of DP. So if I can bring our picture here, here's our picture. They're saying that D, this point here, this point G is such that DQ, this line DQ, it's parallel to the y-axis, and then our DP, which is this one here, it's parallel to the x-axis. They want us to calculate the length of DP, the distance from D to P. So how are we going to go about this one? So if the two Q and D are parallel to the x-axis, it means they are sharing the x value there. The x value at Q must be the same as the x value at D. And we can find the x value at Q. Why? Because we have coordinates there. Okay, so how do we find this? Because this Q is on graph of H, then we can use the graph H of x, which is equals to 3 to the power x. Then we have our coordinate of Q, which is B, is to 1 over 81. And then this is our x, this is our y. Then it means where we see y, 1 over 81 on the graph, which is equals to 3 to the power b. Then we can convert this to be 81 to the power minus 1, which is equals to 3b. Then on your calculator, you say 81, shift fact, then it's going to give you 3 to the power 4. Remember, we're still having negative 1 there, which is equals to 3b. Then it means that 3b is equals to 3 to the power minus 4. So it means the value of b is equals to negative 4. So the value of b is equals to negative 4. So it means at this point, this is negative 4. Then if we found the value of b, it means we know the coordinate of the x coordinate of d, which is also negative 4. So since we found that the x coordinate is negative 4 and we know the x coordinate here, then we know that this is the origin. So from here to here it's negative 4, or it's 4 units. Then from here to here it's 2 units. Then we can add the 2 together. Then we're going to have our dp to be 4 plus 2, and then it gives us 6 units. So from D to P it's 6 units, just like that. Then the last question says determine the values of k for which the equation h of x plus 2 plus k is equals to 0 will have root that is less than negative 6. So what this is saying, we know that our h of x is equals to 3 to the power x. Then now they say we must transform h in this way. So we're going to have our new h of x will be 3, where we see x, we're going to put x plus 2, all right, then plus k is equals to 0. So this is the equation that we're going to be working around or working with. So they want us to determine the values of k for which this equation will have roots that are less than negative 6. So we can rewrite this to be 3 raised to exponent x plus 2, which is equals to negative k, when the value of x is less than negative 6. So we're going to substitute this negative 6 on this x value here. Then we're having 3 negative 6 plus 2 there, which is equals to negative k. Actually, we're solving for k. And then we're going to have 3 raised to exponent negative 4, which is equals to negative k. And then we were going to have 1 over 81, which is equals to negative k. Then our k value now becomes negative 1 over 81. So what this means is that this our equation which says 3 raised to exponent x plus 2 plus k will be equals to 0 if our k value is equals to this value here. So this is the value of k that makes this equation to be equals to 0. And then this is how we answer this type of question. So we just needed to transform the h of x2 to the one that the examiner wanted us to use in order to determine the value of k, for which this will have a root less than negative 6. I hope it makes sense and it didn't complicate you.